Assalamu alaikum. Good afternoon, ladies and gentlemen. I think first I'd like just to thank you, the organizer of this event, because it's the first time for me. I think I am enjoying all this day. And also I'd like just to thank you, the University of New York in Abu Dhabi, and also the Environmental Agency of Abu Dhabi. So first, we start for something. We know this picture is our planet. The planet is blue because from the space we can see the sunlight reflecting in the surface, and that's blue. That is the image we have for at least the water is there for over 4 billion years when the Earth was created. So from this period we are using the same water, and it's the water who is allowing this life, the life we are enjoying today. But 71% of this surface is the water, but 97% is salty water, 2.6% is only fresh water. From this 2.6%, almost 70% is frozen, and we can use it. 30% is groundwater, it's underground, we need to stretch just to be used, and only 1.3% is surface water. From this 1.3%, part of the water is ice, is the clouds, but only 21% is lake waters. So we can use this 30%, more or less only 0.8% of the total water in the world is the water we can use just to survive, to create, to allow the life. Without water, without energy, the life, as we know, doesn't exist. If we remove the surface water, we have more or less 3 small spheres. The first one is the seawater. The second is the groundwater. And in the third is the lakes and river. You can see the diameter of this sphere is 1.3 thousand kilometers, the largest one. The second, the groundwater is only 277 kilometer diameter, and the sweet water where we are in the surface is only in a sphere of 58 kilometer. You can put is also close to Miami, and we cover only the city of Miami. If we compare with the moon is 15 times more volume than the water we have in the Earth. That's what the things we need to preserve. These small satellites who is allowing the life in this planet. The satellites are moving due to the water cycle. But the water cycle, more or less, the majority of the water we are going to the clouds is coming from the sea, more or less 90%. The other is from offshore water. But the majority of the water is coming back to the sea. What is allowing just to share the life into our planet is this cycle. But this cycle is not perfect because compared with the climate change and the population growth, there is a bad distribution. And there is a lot of areas today with the water stress. You can see, but Middle East is in the majority of the countries has in a very strong water stress. Water stress is the water we use compared with the available water. But there is a lot of countries, even Europe, they have water stress. That is created from the difference between the population growth and needs compare what is bringing the water cycle. Hopefully, the water treatment is accelerating and helping this water cycle, allowing just to have water everywhere. It's a problem of cost, but the solutions are available. That is what desalination have today. Desalination is a mature technology with over 60 years history, and today we have around 21,000 plants worldwide in over 180 countries, more or less in the majority of the countries of the world. The capacity of production from all these plants is over 140 million cubic meters per day, and more or less 350 million people in the world, they are using the benefits of the desalination. But you can go there in the graph, what is the production today? Only from this 140 million cubic meter per day built, only 7 million are out of the service. So it's a durable technology, who is an average life over 30 years. The growth in the last year, you can see, is over 8%. In some decades, like years 1920 or 2000, and 2010 was exponential. But today, there is still growing at a very high speed, over 6%. And it's expected in 2030 just to have over 200 million cubic meter per day. That's able just to supply water and water needs from the industry and population for more or less 6% of the water needs. Today, the main source is seawater. It's more or less 60%. 40% is coming from rivers, lakes, and even from wastewater, where it's increasing a lot. The average is around 7.2% of use, but the last 5 years, this usage is around 15%. The second is the percentage, the size of the plant is increasing. And Middle East is one of the cases. They are becoming huge plants just to be more performant and with lower operational costs. Almost 80% of the plants built are used by membranes, around 20% by thermal. But the trends in the last year, despite the chair, you can see in the last 2 years, the new plants, only 1% of these plants are coming from thermal solution. The majority are using membranes, and from these membranes is reverse osmosis the solutions. The type of user is more or less 2/3 municipal and irrigation, 40% industry, and every industry is using desalination in the capacity, not only oil and gas. You can see power, mining, metals, agro-food, pulp and paper, all are using desalination. 50% of the market is in this region, in Middle East and North Africa. The other 50% is there, but the growth of the market is going more in all Asia and Pacific area regions. The size of the plant is larger than the municipal, and the industry is more or less 1/3 of this, the capacity. But the trends today, despite the 60 years of history, they're still growing this market, and we can say the seawater is still who is leading. The brackish is limited. Every year is between 500,000 and 1 million cubic meter per day. Water reuse is taking the relay to the brackish water, but the seawater is taking more and more part of the market. And also, one of the drivers is the energy cost. More or less, half of the cost of the water is coming from the energy, depending on the country, depending on the way to produce the energy. So the energy is one of the main drivers of this market, on these technologies. So I put in this graph, part of the plan, I participate, not the first one, because I was very young when this, but I put my first plan was in the year 83, and the experience we can have is the blue dot is the energy consumption on the one stage of the desalination, only the seawater part. The other is the pretreatment, the transfer of the treated water to the network, and you can see how is the trend. We are in an asymptotic way. What is the limit? The limit is becoming from this technology, the reverse osmosis. And if we put 100% efficiency of every device, we can see, depending on the salinity, if you are in the Atlantic Sea, the maximum with 36 grams per liter, the minimum energy consumption you can have is only 1.5 kilowatt hour per cubic meter. If you are going to other areas like the Red Sea, around 40 grams per liter, the energy consumption, the optimum you can have is 175. So there is a small margin just to win in the following years. That's the target, but it's still field just to improve the things. The overall consumption is increasing the energy, but now we can see we are around 3 kilowatt hour per cubic meter. It was unbelievable 30 years ago when this technology was growing a lot in the years 90. Today, there is only one small potential just to reduce the energy consumption, only less than 10%. You can improve 2.2 or 0.3 kilowatt hour per cubic meter, so less than 2%, 10% we can consume. But we can take profit the lower energy costs coming from renewable energy. And we can link both of these just in order to reduce the water costs. At the same time, we are minimizing the carbon footprint of the desalination plant. That is the main trend. The second is just to ensure the availability, the reliability of the plant, and the operability of the plant, minimizing the operational costs. That's the trend. Desalination is becoming like a traditional drinking water plant, just to improve operation year by year in order to ensure the water distribution to the population at the same time at a reasonable cost of the production. So the trend is just to improve the membranes, being more performant, having less energy just to produce, be more robust, but all the equipment around these devices need to be more reliable. The biofouling control is one of the targets, and there is a lot of trends just to trying to improve, but also just to reduce the use of chemicals in this plant. The membranes of the classical treatment is a case by case, depend of the cost, depend of the region you are applying, but both solutions are applicable and both are progressing. But the main driver is also to respect the environment. You have understood what is the brine, what is the discussion there is around the brine in these kind of things, and the misperception there is about this target. The membranes are a key point, and there is a lot of progress. Today, there is new generation of membranes. There is a fight between several types of membranes by the materials, PVDF versus polyether sulfone, in, out, in, multi-bore, single-bore. I think the last year, there has a lot of progress. Now, there is more robust membranes. But we are still expecting new membranes, new materials for the membranes in the following 5-10 years. And that's a challenge we need to solve. But also, in the heart of this technology, in the iron membranes, there is a lot of new material could be applied. There is under the research, both of them, graphene oxide, carbon nanotube, nanoporous graphene, or even biomimetic membrane using biology inside the aquaporin. But the trend is instead to wait a lot of time just to have the solution of these kind of things, is just to have first an hybrid solution using the existing technology with the new trends. That is the way just to go step by step progressing in this technology, using the actual one. But the last trend coming from especially from seawater desalination is going to the brine, using the brine as a source. How? Blending with another source of water, even treated wastewater, just to produce more water and keeping the same volume of the brine, not doubling the volume of the brine we are sending to the sea. And there is several technology, and despite the chairs, this technology are going just in two ways mainly. I just summarized only 5 technologies, but it's at least 25. The first is using just to recover either the water or either what is dissolved into the water, salts and metals, and the other, they are going just to produce power at the same time they are treating and recovering this brine and the wastewater. The first is the pressure retarded osmosis, the second is the solvent, the liquid ionic membranes. In the other part, we have the reverse electrolysis, the nanotubes, or the accumulator mix, just to put 3 typical examples where we are using that. The first, they are absorbing energy, electrical of heating, and the other, they are producing energy using the salinity gradient power. So using the difference of salt to create an electrical current. At the same time, we are treating the water. That is beneficial because it's reducing the operational cost. At the same time, you have barriers between the wastewater and the brine. This technology, I think, that has a promising future because you don't need to break the existing technology, are complementary. You can increase the production, at the same time you recover the soil minerals, produce energy, recover the water, using the wastewater reuse, and even producing sun energy. I think it's one of the trends we expect just for the following years. The water reuse is the other market promising. Today, they are growing even at high speed compared with the desalination. Every year, there is new plants producing between 6 to 8 million cubic meters per day, new plants. And more or less, the total cumulated capacity that's arrived more or less at the same volume of desalination. But both solutions are complementary. But there is still a lot of problems just to solve with water reuse. The main one is just it's quite difficult to implement because in the majority of the countries there is not an integrated water management. So it's quite difficult just to have both solutions at the same time because there is two different ministries or two different entities who are handling this decision. The other is a problem of water costs or water tariffs. To recover the cost is a key issue. The regulation of the lack of regulation, I think it's a barrier just to develop this solution. And they need more promotion from the technology and also from the public acceptance. It's one of the other key points. What is water reuse? For me, there is 4 types of water reuse. The basic water reuse or de facto, as we have in Europe, for example, we have a regulation implementing how it must be the discharge to a water body, a river or lake, in order to protect what is inside, because previously or after there is a drinking water plant. So it's reused de facto, this water. That is the same example in the majority of the developed countries. The second is the tertiary, when you improve the treatment just for example, just for irrigation from the agriculture. The other two, they have the trends in the last 20 years, is an advanced tertiary, just improve the treatment in order to get a better quality in order, depending what is the water use. And the 4 is more destination just to go to the indirect potable reuse or direct potable reuse, is the multi-barrier concept. To be sure that nothing is going through this solution impacting the human health. The 2 first is using 75% of the volume and 25% of the market. The 3rd and the 4 is 75% of the money, 25% of the volume, but it's the more technological. Today, the water reuse is not a problem. It's not a technological problem. We have solution for all these kind of things. The only way is we need to spend a lot of energy and money to implement this solution and to promote this solution. What is the market of the water reuse? If we start by the upper part, we can see the world water consumption by UNESCO is 70% is from irrigation, any kind of irrigation. It's more or less 20% in the industry, 10, 11% is for urban use, from drinking water mainly. 5 years ago, the water reuse practice was more or less reflecting this mapping. 75% is for agriculture, landscaping, urban usage, 20% from the industry, and less than 5% just for IPR or DPR. But the last decade has changed a lot. That's the graph we can see in the other. Today, we can say, and the driver is coming from the Asia-Pacific region, and mainly China, is changing this trend. Today, we can see it's over here. 45% is used in the industry, 55% by irrigations, all included, and 5% from IPR or DPR. But there is not the only trend. Wastewater reuse can be only used if you treat the wastewater. So the other trend is just to treat the wastewater. And the wastewater is also an opportunity, because if we try to reflect the complete cycle of the wastewater, there is a lot of trend just to invest in innovation in treatment, but also to reuse. But not only there, the biosolids produced by the water treatment, they have a lot of opportunity. And the opportunity today is to recover what is inside, has a recovering of many resources. Even fertilizer, recovering phosphorus from the centrate coming from the digestion, trying to treat as much as possible just to recover all the energy coming from the biosolid and having more drier biosolid to be used as a fertilizer or to have another valorization, another life, like a custom combustible, for example, or producing energy, incinerating it, or using the biogas not only just to burn and to produce electricity. We have another use, like today in Europe, and there is a trend just to use the biogas treated, even recovering the CO2, and using in urban services, buses, taxis, using liquefied or non-liquefied compressed gas. So we are completing the cycle, and there is a lot of opportunity for innovation just to recover all the resources we have in the wastewater. I think that's the last one, but I think with this one I try just to give a different image of what wastewater is giving to the other, not only desalination water use. Thank you very much.